Hey math kids, today we're going to talk about optimization with quadratics, and that's basically just finding like the smallest thing or the biggest thing using quadratics. So the first one says find the maximum or minimum value of the following quadratics and the corresponding value of x. And so if you understand that this is a positive, so meaning the number that's in front of x squared is a positive number, then we know we're going to have a situation like this, which means the vertex is going to give us a minimum. Okay, so this answer that we get is going to be a minimum. Now, there is a axis of symmetry equation where x equals negative b over 2a. And so I would use this. And so for this specific one, we get negative 1 over 2 times 1, which is negative 1/2. Now, this is the x value of the vertex. So if we plug this in up here, we get negative 1/2 quantity squared plus negative 1/2 minus 3. And square the top, square the bottom. So 1/4 minus 1/2 minus 3. We want common denominators, so multiply this by 2 over 2. This is like 1, multiply this by 4 over 4. So we get 1/4 minus 2/4 minus 12/4. So that's negative 14 plus 1, so negative 13/4. Okay, so the minimum value is going to be this number. And then it occurs at this x value. So it asks for those two things. So really it's just saying find the vertex and then tell me whether it's a minimum or a maximum. Okay, we'll try another one. This is just part B of the same question. Okay, if it's helpful, rewrite this as negative 2x squared plus 3x plus 3. If you feel like you can keep that straight, then don't worry about that. Now, because the leading coefficient, or the number in front of x squared, is negative, we're going to have an upside down parabola, so this is a max. So a maximum. But we're going to do everything the same way. So negative b over 2a. So we get negative 3 over 2 times negative 2. And so those negatives would cancel, and we end up with 3/4. So that is the x value. Now, if we plug that in, we get negative 2 times 3/4 squared plus 3 times 3/4 plus 3. Okay, 3/4 squared is going to be 9/16. And then if we times that by 2, we can just cancel it with the bottom. So like dividing the bottom by 2. So that's going to be negative 9 over 8. Multiply these together, we get 9. This is like 3 over 1, right? 9/4, and then plus 3. Okay, so I'm just focusing on this part. Let's do that. Okay. Now, we want common denominators, so we need this 8. So we're going to multiply this by 2 over 2. We think that of a 1, multiply by 8 over 8. So we get negative 9 over 8 plus 18 over 8 plus 24 over 8. Okay, if we combine just these first two, 18 minus 9 would be 9. And then if we add 9 to that, that's 6 plus 3, so 33 over 8. And that's what goes right here. So we have 3/4, 33 over 8. So 33 over 8 is the maximum. And then this is the x value where that maximum occurs. Okay, now they're going to give us a story problem to put this to see if we really got this. So it says a gardener has 40 meters of fencing to enclose a rectangular garden plot where one side is an existing brick wall. All right, so we're going to draw this. We have a brick wall that already exists, and then they're going to build a rectangle. So these will be the same. All right. Suppose the two new equal sides are x meters long. So this is x meters. This is x meters. And then it says, show that the area enclosed is given by this. All right, so they're going to kind of walk us through this. I guess that's kind of nice. Okay. So they basically want us to explain what this means. Now they give us that this is x, this is x. So when we're thinking of area, it's going to be whatever this length is times x, right? So length times x. Now that's where this x comes in. That's, this x. So it's x times, so this is claiming to be the length. Now we know we have 40 meters of fencing. Okay, so this plus this plus this needs to be 40 meters. And so if we called this 40 meters, that wouldn't work out because these would both be 0. But if we have 40 meters minus x, or minus 2x, then hopefully that makes sense. So it's 40 minus 2x because the entire thing needs to be 40. So this would be 40 minus whatever this is, minus whatever this is. And those are the same thing, and we're calling them x. And so this really is just the length. And hopefully that made sense. So you just need to put that into words somehow and explain that this is really just length times width, and the reason why the length is 40 minus 2x. Okay, now we want to maximize this area. We want it to have the greatest area possible. And so we're going to distribute this first. And so we get 40x minus 2x squared equals the max area. Now, if we were to graph this, it would be an upside down parabola, and there would be a maximum. So really, all we need to do is figure out what that y value is right there, and that's going to be our maximum. So we're going to take this piece and do our negative b over 2a, because that'll tell us the x value that makes this the maximum. And so this is written backwards, right? So this is our a, and this is our b, and then our c is actually equal to 0, but we don't need to use it. Okay, so our b, we get negative 40 over 2 times negative 2. So that's negative 40 over negative 4. Negatives cancel, and so that's 10. And so the x value that gives us our maximum is 10. And so all we need to do is plug in 10 to this. So we're going to say 40 times 10 minus 2 times 10 squared, and that will be our maximum area. So 40 times 10 is 400. And then this is going to be negative 2 times 100. And so that's going to be 400 minus 200, which is 200. Okay, so 200, it's a length, so it's going to be meters. And now we just need to write our sentence. So I forgot, what is this, a garden? Yeah. The maximum area of the garden is 200 meters. This occurs when x is equal to 10 meters. All right, so if you need additional help, come to Math Lab, but until then, calculator.